All right. What? It dinged? We didn't get another one. Okay. Liana and Carla online. Okay, no Angelina, no Zeph today. All right. Good afternoon, everybody. Today is going to be possibly a super fun day, possibly a depressing day. Depends on how you look at it, honestly. Because today we are going to be studying how to be wrong. That is to say, we're wrapping up our laws of logic with looking at some logical fallacies, right? Bad logic, so that you can either, in a more positive attitude, use it to point out the mistakes of other people. Ha ha, you're wrong, here's why. Or use it to reflect on your own work and be like, oh, shoot, I did that wrong. That's not good, that's bad. Oh, I got to change that. That's the depressing bit, right? When you realize you're wrong. But for some reason, humans seem to always get a kick out of telling other people that they're wrong. But they never like admitting that they're wrong themselves. So it's two sides of the coin here, all right? And I'm going to start with rebooting Chrome, as always. Okay. The Wikipedia page on list of fallacies. There's a lot of ways to be wrong, which kind of makes sense. If there's only one way to be right, that would mean everything else is wrong, right? But we're going to narrow that down a lot shorter for today. We're only going to take a detailed look at two of them. Here's why. First of all, the bounds of logic itself versus all of arguments, okay? We're only talking about logical arguments, purely logic and reason. We are not addressing, if you've ever studied argumentation in English class, an argument essay, right? There's the logos, ethos, pathos, those different ways of convincing people of stuff. That's also part of an argument in the rhetorical sense, but we're only in the realm of logos. So we're eliminating all that other stuff of appealing to emotion and making you feel good and making you know, like, I'm on your side, therefore you should agree with me. That's not what we're talking about. Purely logical. And then there's related to that, we're looking at, again, a fallacy here is logically incorrect, which means the logic is the part that's at fault, not necessarily the conclusion. Okay? There's actually a such thing called the fallacy, and that is to assume that because somebody made a logical fallacy, that means the conclusion is automatically false. That's not the case. It just means they did a bad job of arguing for it. Okay? The existence of a fallacy doesn't make the content true or false. So that's what we're avoiding here today. The other branch of these fallacies would be the content or the informal fallacies. That has to do with within the argument someone is making, they are making an appeal to authority. That could be another one. Oh, because this guy knows so much about it and he's making the argument, it must be true. We're trusting in it because of the authority of the person making it. That's an appeal to authority. That's a logical fallacy. Right? It is giving a reason you know it to be true other than those 4 laws of logic that we already know and love. Anything else is a fallacy. Right? And so if it has to do with the content, you're adding in some other type of reason, that would be an informal fallacy. And that is also a large part of the list here on Wikipedia that we're not addressing today, but you can take a look at. The study.com work this week, those homework lessons deal mostly with informal content-related fallacies. Okay? So you can go back to those if you've did them already. If you haven't done that, you've got till Friday. Check that out, and you'll see some of those. What we're going to look at today is the formal fallacies dealing with the structure. Okay? Remember, I've been saying that when doing logic, the focus is on the structure. You don't need to know anything about the content in order to make a determination of whether or not it's logically valid, because it's purely structure-based. We can translate any argument into symbolic representation, okay? Set up those symbols in the structure presented and match the structure. If it matches one of the 4 laws, it's valid. If it doesn't, it's invalid. And we're going to take a look at the 2 most common ways that structure gets misused. Any questions so far? Okay. So, the 2 most common logical fallacies are affirming the consequent and denying the antecedent. These are misapplications of our laws of logic. They are really close. So it can seem to the average mind that, oh yeah, I'm following a logical law here, I'm good, this is valid. And it's like, oh no, you were so close, but not quite, you missed it by that much. And now, hopefully, by giving a name to these, you can see them and recognize them more often. Most importantly, in your own work, as you're going to be doing here throughout the rest of the year, you're going to be applying this logic stuff to all kinds of content. And I want you to be able to realize, ooh, wait. No, I can't say that. Okay, change that, erase, redo. I was about to affirm the consequent. We can't do that. All right? And then outside of class, maybe you can make it more fun. And you can tune into the news every now and then and listen to the pundits on TV talk about this and that, and oh, this is happening, and therefore this, and I conclude that. And you'll be like, hey, wait a minute, talking TV space guy. You're falling for one of the classic logical fallacies. You're wrong. I'm not listening to you. Right? Because they do it all the time. Especially this first one. Affirming the consequent. Oh my goodness. It's not just a problem with students. Full functioning adults do this a lot. What is affirming the consequent? Affirming the consequent is the logical fallacy of inferring the truth of the antecedent of an implication from the truth of a consequent. Remember, an implication was another name for our conditional statement. If P, then Q. The antecedent is the part that comes first. We call that the hypothesis. The consequent is the conclusion of our conditional. Merriam-Webster likes to use fancier words for it. They all mean the same thing. Okay? Antecedent and hypothesis, consequent and conclusion. Many terms. I just like the succinctness and the included example of Merriam-Webster's definition. That's why I've used it here. All right? But this is saying we're going to have not only the conditional, but we're going to reaffirm the consequent, right? We're going to state that conclusion again as a separate statement. And from that, conclude, therefore, P must be true. If P, then Q, I've restated Q, and we're concluding P. We're going from Q to P. That's not the direction the arrow goes. That's wrong. That's committing the logical fallacy of affirming the consequence. You worked backwards. You weren't supposed to do that. Here's their example. If it rains, then the game is canceled. Typical scenario for a lot of outdoor sporting events, right? And then we're told, oh, the game has been canceled. And they conclude, therefore, it has rained. That's not a safe conclusion to make. Is it? Let's imagine that scenario. You're anticipating going to the sports game, right? And then you find out, oh, you look up online right before you're going to go, you check your phone, but, oh, event canceled. What? Oh, shoot, it said if it would rain, it would be canceled. Does that mean it's raining right now? No, there's all kinds of other reasons a game could be canceled, right? Bless you. Maybe somebody got sick, right? The umpire is late, right? Someone forfeited. Game over, right? Who knows why the game is canceled? Could be other logistical issues. You don't know whether or not it's because it's, you want to check if it's raining? You can look outside, right? It's very easy to determine that. You just need more information. This doesn't say it's guaranteed to rain. It doesn't say it's guaranteed not to rain. We need more data to conclude anything about the rain. What they've done here, another way to think of affirming the consequent would be you are assuming the converse is true. And remember, the converse is what happens when you reverse the order of your conditional. Instead of if P then Q, we're saying if Q then P. If we had that, if we have this guy, Q into P, and we can state Q, then we could conclude P and we'd be following modus ponens. That would be valid. But we don't get this guy automatically. We started with this one. Those are two different statements. You don't automatically get one from the other. They are not logically equivalent. The converse is not necessarily true. It could be the case. It could be still be raining. That could be why. We don't know. We need more information. Okay? That's why this is so common. So many people assume really what they're assuming then. Only if it rains, then the game is canceled. That's what a lot of people like to add in there. They think just because I said rain, that's the only cause. It's not the only cause. If you can come up with another reason why, it's not a valid conclusion, right? Questions on affirming the consequent? Okay. Double check this. Right. Next is much like it, denying the antecedent. Using the same phraseology here. The logical fallacy of inferring the negation of the consequent of an implication from the negation of the antecedent. Aha. So once again, we have our implication, our conditional statement, if P then Q, except this time we are also given not P. The first one didn't happen. It's not the case. Oh, so we're going to conclude, therefore, not Q. No, you can't do that. You can't just deny it because I didn't say P was the only way to get to Q. Just because we're missing that one does not mean you can conclude not Q. That's a fallacy. Use the same example. If it rains, then the game is canceled. It's not raining. Does that mean, therefore, the game is definitely not canceled? You don't know that. Anything could happen. You're all set, ready to go. You've got your tickets. Everybody in the car, drive on over. The sun is shining. It's not raining. The website said, if it rains, the game will be canceled. But it's not raining. Are we good to go? Are we guaranteed the game is still going to happen? And why is there nobody in the parking lot? This is weird. Hey, the gates are down. It looks closed. Are you sure the game is still happening? It's not raining. Didn't say rain is the only way. There's other things that could have caused a game to be canceled. There's other ways we could have gotten the statement Q. We just weren't informed about them yet. You need more information. So this is a case of assuming the inverse is true. Remember, the inverse is when I negate both sides of my conditional. If not P, then not Q. If I had that guy instead, yeah, given not P, I could conclude not Q, but we don't know this. That is not for certain. That is not guaranteed. It does not come automatically just because we have a conditional. You can't just negate the whole thing and expect to get matching results. It's not logically equivalent. Now, what is logically equivalent, if you recall, is the contrapositive, and that is when you do both things. You reverse the order and you negate both sides. One of those mathematics, two wrongs make a right, or two negatives make a positive kind of deals. But just one or the other, you're going to fall for one of the most classic, most common logical fallacies. And you'd be wrong. Or maybe somebody else is wrong, and you can point it out to them. And you say, ha, you're wrong. Here is why. You have affirmed the consequent. And then you sound all smart. You're using fancy terms. Right? Good stuff. Questions so far? Okay. Then your task today is to go through these 10 statements. Yeah, 10. And identify these arguments as either affirming the consequent or denying the antecedent. You can abbreviate them AC or DA, respectively. Or they might actually be valid arguments. I think one or two of them are. It's up to you to find them. And then you can just write valid. All right? In fact, I took these arguments from some of our past classworks and exercises of previous sections. All those times when we came across one that said, oh, we just said invalid, this didn't work. Well, now you get to go and revisit some of those and determine exactly why it didn't work. Which fallacy were they falling for here? All right? So once you have labeled those, upload your work, and you'll be done for today. Yes? Yes. Before you take off, hang on, wait. One final reminder, okay? Next week is testing, right? End of the quarter. On Friday, you've got the online test. That'll be Google Forms, short answer, multiple choice kind of format stuff. On Wednesday, you have the writing portion, the essay bit, where you get to write out, type up your logical argument. Okay? That's going to be on a Google Doc. That's going to be during your class time. I'm requiring all colors to report in. Even if it's not your assigned day, join in the Zoom. You'll be given access to the document. You have that class time to finish it, right? So it's a timed assessment. Okay? If that would cause you some kind of schedule conflict because you thought you had the day free of class time, you had something else scheduled, email me, let me know. We'll set up an alternative time. Okay? And then in preparation for that, this Friday I will be posting a review packet for you to work on over the long weekend. All right? Questions there? All right, you're good to go. I'll leave you the rest of class to work.